Good day, y'all. Warp Tech here, and I want to explain why fine tuning seems ridiculous, in my opinion. In the variable speed of light model, or as I should say, the polarizable vacuum or the relative damping interpretation of general relativity, because it's not really a different theory, it's the same equations, the same math, but a totally different interpretation of what Einstein's equations are telling us. Refer back to my last video and a few before that where I discussed this. Here I want to go over the idea of the physical constants being constant and why we're fooled into thinking this, when in fact there are an infinite number of variations of the physical constants that lead to this reality, just at a different scale. And we would never know it by measuring locally. And just to start, if you consider a variable speed of light model, then space and time, or time and distance, are variables in that model. And when you do a proper dimensional analysis, that length is contracted, time is dilated, and you put space and time into all the other SI units of measure and constants, we find that, and let me put this in a simple way, we're going to abbreviate the radial Schwarzschild solution as a refractive index, and we're going to call it K. K is the refractive index of the vacuum at the radius r from the center of mass of a planet or a black hole or something like that. So K increases as you approach the center of mass. When the speed of light is variable and it is slowed by, becomes C divided by K. This is the refractive polarizable vacuum speed of light. It's a variable. In this model, lengths are contracted. Inside the gravity well is contracted by multiplying or dividing by the square root of K, multiplying by 1 over the square root of K. Time is slowed down in the gravity well by multiplying the time interval by the square root of K. So when you do this in dimensional analysis, energy inside the gravity well as compared to outside of the gravity well, and I'm referring to like the energy state of an atom, is lower. First, before we get into other things, let's take a look at the fine structure constant. E squared, electric charge, divided by 4 pi E naught C H bar. E naught, in order for C to vary like 1 over K, or I should say in order for the speed of light to vary like C divided by K, we have that C squared is equal to 1 over the square root. C squared is equal to 1 over mu naught E naught, where mu naught is the permeability and E naught is the permittivity. So to get C over K, we have to multiply E naught and mu naught by K. And this is what we find in Hal Puthoff's polarizable vacuum model. I'm not going to go into the history of it. There's plenty of it. It's even got its own Wikipedia page. So in this model, the fine structure constant doesn't change because K E naught cancels the K in C over K. So if you substitute the PV model variable speed of light and variable permittivity, the fine structure constant remains constant. So that one isn't affected. Also, Planck's constant was derived as a conversion or a constant of proportionality between what was previously defined as energy and what was currently being defined or experimented with is the energy state and frequency of quantum systems. And Planck determined what the value of that proportionality would be. This is not affected in a gravity well. Planck's constant is still a constant even in a gravity well. The fine structure constant is still constant even in a gravity well. An electric charge, which is also a coupling or a proportionality constant between energy and voltage. Voltage having its own definitions in historical definitions. An electric charge in the CGS unit system, you don't even use coulombs. So it's a constant of proportionality. It's the same inside and outside of a gravity well. What varies are the things that are proportional or dependent upon length and time. Because in a gravity well, our instruments for measuring length and time are variables. Rulers contract, clocks run slow, and when we use these tools to measure the speed of light, we get a constant value because they all change consistently. The beauty of this scaling is the reality we're in right now can exist at an infinite number of values of K. K is not a constant. K changes between where I'm holding my coffee now and where I'm holding my coffee now. It's not the same value anymore. And that goes true all the way up and down. We're in a gravitational well, and K is a variable, so the speed of light is a variable, time, length, and clocks run slow, length gets contracted, length gets expanded, etc. And so do dimensional analysis on all of the constants. Do it. Put the length divided by the square root of K and time multiplied by the square root of K, and anywhere you find in the units of measure, length and time, substitute those two things. Anywhere you see the speed of light, C, replace it with C over K. Anywhere you see E naught, replace it with K E naught. Anywhere you see mu naught, replace it with K mu naught. Go through all the physical constants and you'll find that the ones I mentioned, electric charge, Planck's constant, Boltzmann's constant, fine structure constant, are pretty much the only ones that are constant. Even G, big G from gravity, is a variable. In fact, that one varies the most out of all of them because it varies proportional to 1 over K to the 4th. And this is because forces are not variables. The force between the electron and the proton in a gravity well is the same as the force between an electron and a proton far away from the gravity well. And that means that G over C to the 4th, the one Pais calls the superforce, or C to the 4th over G is the superforce, and the one Jack Sarfati has his variable refractive index to the 4th power. Well, this is wrong. You can do it that way. But the dimensional analysis tells me that if C to the 4th varies like 1 over K to the 4th, G also varies like 1 over K to the 4th, so that C to the 4th over G does not vary inside or outside of gravity well. So modifying that, if there is a way, will be very difficult. Right. There's one other thing I wanted to point out, and that is mass is energy. When you consider length as a variable and time as a variable, and you look at acceleration, acceleration is length divided by time squared. You find out that acceleration is a variable in a gravity well. So deeper in the gravity well, the acceleration is affected by 1 over k to the 3/2. All right, so the square root of k cubed. That's acceleration. Remember a moment ago I said where forces aren't affected? So if force isn't affected, then mass times acceleration isn't affected. Mass varies as times k to the 3/2, so that the k's cancel out. Mass times acceleration inside a gravity well is the same as mass times acceleration outside a gravity well. And this is necessary. If forces varied, that would screw up the universe. But because forces are consistent at all points in the gravity well, until we get to some nonlinear effects, and I am talking about a linear model at this point, although it can change, it can be modified. The forces don't change. So the scaling is consistent, and we can't observe it because we only observe forces. So all those constants of nature that I mentioned vary, except for the 4 that don't. And this allows matter to scale conformally, as in conformal gravity, in a gravity well. It's great. It's awesome. It works. And this is just an alternative interpretation of general relativity. It's not a different theory. I'm not talking about some crazy out there theory. I'm just talking about the mathematics of general relativity interpreted from the standpoint of the right-hand side is what exists, and the left-hand side, g mu nu, is what we measure with the stuff that exists. And getting back to my point is that if mass is going into a gravity well where k is stronger, the mass is increasing. K times m times k to the 3/2. So mass is increasing as an object falls into the gravity well. But its energy, which is the energy mc squared, is divided by the square root of k. And you can see that because m times k to the 3/2 times c squared over k squared gives you 1 over the square root of k in the denominator, just as we were talking about before, making voltage also 1 over the square root of k, and the electric charge just a constant of proportionality between energy and voltage. So falling into a gravity well, energy is being lost, but mass is being gained. They're not the same. Mass depends on how difficult it is to accelerate. It's not some little tiny ball with mass. It's all part of the kinetic energy of the system. And where the speed of light is slower, it's harder to accelerate. So it appears as mass increase. Anyway, I hope this helped. It's Warp Tech out. Don't forget to like and subscribe.